In this video, we're looking at how to factor trinomials. When you're factoring trinomials, remember, you're trying to essentially express the trinomial as a product, right? And that product is going to be two binomials multiplied. So what we're looking for is two binomials that when multiplied form the trinomial. The first step we'll always do is look for the greatest common factor. I don't see a greatest common factor in example A, but I do see that it's a trinomial, so I'm going to go ahead and draw my two parentheses. And we're going to use essentially a trial and error approach, but we're not going to be completely guessing. What we're going to do is we're going to look at this last term here, this number here, and we're going to look for factors of it. And then we're going to look at the sign that appears here. And we're going to use that sign to help us determine how we can come up with the term in the middle. So let's go over how this is done. We're basically going to say, what factors of 12 add to 7? So what factors of 12 add to 7 is the question we're going to ask. What factors of 12 add to 7? Okay, so what's going to change depending on the problem is going to be essentially these words, right? Because the add comes from where? Well, add comes from the fact that this is a plus sign here, right? That's why we say add. Now, the 12 and the 7, of course, are specific to this trinomial. If it was another set of numbers there, we would have a different set of values, of course. But in this case, we're thinking about what factors of 12 add to 7. So let's list the factors of 12. If you list them, you're going to list them in pairs. So what I want you to do is kind of say, okay, well, 1 times 12 makes 12. And then, of course, we have 2 times 6. So we're just going in order here. Then we have 3 times 4. Now, at that point, we can stop because 3 and 4 are right next to each other. So obviously we'll just be, if we go to 4, it'll be 4 times 3, and then obviously we've already got that answer written down. Now, from this list, we're going to basically use trial and error to see which one works. Now, you can of course check the logic of this statement and say, well, which of the pairs here add to 7? And I think we can see that in this case, it's 3 and 4. It is very often this pair that are closest together that is the solution. So we should always try that one first anyways. So 3 and 4 are close together compared to, say, 1 and 12, which are 11 steps apart. 3 and 4 are only one step apart. So we'll generally try to do the 3 and the 4 first. And here it's very clear that 3 plus 4 does indeed give us the 7 we're looking for. So what we're going to do then is write down the x squared, the first term of this trinomial, in the beginning or front part of the parentheses that we have written on paper. And then we're going to remember something important. This plus sign is going to indicate we have two of the same sign, and that sign is going to be positive in this case. So it's very important to remember that if the last term is positive, it means that, so we have plus 12, right? So that's a positive number. What we're saying here is that because that's positive, it means that our parentheses here, the two binomials, will have to have the same sign. The question is it going to be two positive signs? So is it going to be two pluses, or is it going to be two negatives? That's the question we have to answer. But we can figure that out by simply looking at the sign of 7. When you look at 7's sign, it's positive, so it must be that it's two plus signs. All right, good. Now the last thing we need to do is fill in the two factors that we mentioned, 3 and 4. So if I put 3 here and 4 here, I think I have my factoring. Now, to be sure, I'm going to test. So to be sure, I'm going to test, and the way I'm going to test that is simply multiply the two inside terms and then multiply the two outside terms. So we have this little checking method. So 3 times x is going to give me 3x, and the x times the 4 is going to give me 4x. Notice they're both positive. Then we add them together or combine them, and we do indeed get 7x, which is the middle term of our trinomial. So that's our factoring then. Okay, so that is our solution for the first problem. Let's look at problem B then. In problem B, again, it's a trinomial. We check for a greatest common factor first, because this first term has no numbers in it, and the last term has no variables in it. So it is pretty safe to assume there is no greatest common factor for this trinomial. Now, with that in mind, then I'm going to draw my two parentheses, like we always do for trinomials. And we're going to split this first term up into the first position in the parentheses, so x and x. And then we're going to look at this sign here, the sign at the end. If that sign is positive, remember it means two of the same signs for inside the parentheses. So that'll be two of this sign, the sign in the middle, and that sign is negative. So again, just to recap this rule again, if this last sign is positive, it has to be 2 of the same sign inside the parenthesis, and that sign will be the sign you have here in the middle of the trinomial. Okay, with that, we always ask that same question again. What's the question is, what are the factors of 8 that, in this case, add to 6? So, what factors of 8 add to 6? Again, add here because of the plus sign again, right? All right, so what are the factors of 8? Well, let's think about it. We have 1 and 8, and we have 2 and 4, and then 3 doesn't go in there, and 4 brings us back to 2 and 4, so we basically have all the factors, just 1 and 8 and 2 and 4. All right, we always try the closest pair first to see if it works. And sure enough, 2 plus 4 does indeed add to 6. So if we put 2 and 4 here, we are done. To check our work, we do the inside product, which would be negative 2 times x, which is negative 2x, and then we do the outside product, and that'll give you negative 4x. If these two add to negative 6x, which they do, then we've done our factoring correct. All right, let's look at example C then, for example C. All right, so with example C, we're doing the same idea again. We're basically saying, is there a greatest common factor? Again, since there is no numbers in front and no variables in the back, we cannot have a GCF. So since we know there's no GCF, we're going to try to factor using the 2 parenthesis idea. And let's go through the logic here again. The first term gets split up in the first position of the parentheses, so x and x. Then we're going to look at this sign, and this is important here. If the sign in the back end is negative, if the second sign is negative, it means we're going to have a sign of each for the parentheses. So plus and negative. Has to be that way, because the only way you get this last term is by multiplying 2 values with different signs. So it has to be a positive and a negative. You don't have to worry about it. It's a guaranteed thing. It's a rule. Can't be changed, can't be violated. So you know it's going to be a plus and minus. Now from here, you're going to ask that same familiar question, which is what? What factors of 4, this time we're going to say subtract, to give us 3. Now this is important here. It's subtract here because of the negative sign here, right? That leads to the phrase subtract. All right, so we know we're going to be subtracting, and we're looking for factors of 4 that will subtract to give us 3. Well, if you think about the factors of 4, there aren't too many, right? There's 1 and 4, and then there's 2 and 2. Now, 2 and 2 subtract to give you 0, so that combination will not work. But 1 and 4 indeed does work, because 4 minus 1 is indeed 3. So we have 2 factors of 4 that subtract to give you 3. So the only question is, which place do I put the 4 and which place do I put the 1? It matters here because the signs are different. I'm going to give you a for example where we do the problem incorrectly. What if, for example, I put my 4 here and my 1 here? What happens? Well, in that case, we end up with positive 4x, because a plus 4 times a positive x gives you 4x. And then we have, with this product here, a negative 1x, leaving you 3x, but that 3x is positive. Our middle term is actually negative, so that won't work. So we need to do something else. And the answer is obvious. We need to just switch the location of the 4 and the 1. Okay, so let's switch around the location of the 4 and the 1, this time making the 4 negative and the 1 positive. Then we'll have 1 times x, which is simply 1x, and negative 4 times x, which is negative 4x. You combine these now, and you do get minus 3x. And there it is. That's our middle term that we were looking for, so the factoring above is correct. Okay, for our last example, we're going to look for greatest common factor first. We always do that. And this time, I think we do have a greatest common factor. I believe 3 goes into every term here. This 3 can be divided into 3 itself. It can go into 15, and it can go into 18. So I think 3 is common to each of the terms. So let's pull out a 3 before we do anything else. So 3 goes into itself 1 time, leaving you just x squared. 3 divides into negative 15, negative 5 times, leaving you a negative 5x. And 3 goes into negative 18, negative 6 times. So this is the greatest common factor factored out. Now from there, I do need to check to see if the trinomial will still factor. It might still factor, right? Greatest common factoring is the first step of the process, but it isn't the only step. So let's bring it down first, though. Never forget to bring down your greatest common factor first. It's a common mistake to leave it out after you've done the factoring for the trinomial. So you want to be careful with that. All right, with the x, you're going to break it up as x and x. You're going to look at the sign on the back end. You're going to say, okay, that sign is negative. That means I have to have a sign of each. So I'll do plus, minus, for example, right? And then we look at 6. Let's go through that sentence again out loud. It should be factors of 6 that subtract, in this case, right, because of the negative sign. Factors of 6 that subtract to give you 5. So what factors of 6 subtract to give you 5? Well, let's see. We have 1 and 6, of course. We have 2 and 3. And 1 and 6 are the ones that subtract to give you 5. Notice that 2 and 3 add to give you 5. But we know that our signs are different here, and we know that we have this minus sign here, so we're forced to say subtract to give you 5. That's really important. So remember that you have to follow the strict rule of the signs, otherwise you will not get the right answer. So we're going to assume again that it's subtraction, so we're going to use 1 and 6 as opposed to 2 and 3. So 2 and 3 don't work, but 1 and 6 do. Now I'm going to make the 6 the bigger one because it's negative, and we want the middle term to be negative, and then we'll put 1 here. And this will check out, but let's do the check just in case. So 1 times x is 1x, and then we'll have x times negative 6, which is negative 6x. And of course, when you add them, you get negative 5x, which is indeed our middle term, so we've done this correctly now. Okay, so our final answer then is 3 times x plus 1 times x minus 6.